Hello everyone, today I will be teaching you class 9 chapter 1 matter in our surroundings. Here the first word is matter. Let's see what is a matter. So anything around us that we see, for example this board, your book, your pen, anything that you see around you, it is made up of matter. And it occupies space. Yes or no? This board is occupying some space and we know the weight. So it is occupying space and it also has mass. So that is called a matter. And also this matter is again made up of particles. Tiny particles, many tiny particles, they make up the matter. And these particles have three characteristics. One is they have space between them. They are continuously moving and they attract each other. But before going to these characteristics, we must know that there are three states of matter. The matter, they exist mainly in three states, that is number 1, solid, number 2, liquid, and number 3, gas. Now let's go to the details of this. We will compare solid, liquid, and gas in these three characteristics of particles. Since they are all matters, they are also made up of particles. So let's see the spaces between the particles of matter in solid. In solid, the space between the particles are very less, and in liquids the space between them is quite high. That is, as compared to solids, the liquids have more space in between the particles, and then gases have the maximum space between them. So that is why gases can flow here and there. Next is they are continuously moving. So in terms of movement, in solids, the particles of matter, the movement is quite low, or minimum in solids, more in liquid. Minimum in solid, more in liquid, and maximum in gases. The movement is maximum in gas, intermediate in liquid, and minimum in solids. Now going to force of attraction. We know that they attract each other. The particles of matter, be it solid, liquid, or gas, they attract each other. But the force of attraction is much higher. The maximum is in solid, intermediate in liquid, and less or minimum in gas. The force of attraction between the particles of matter in solid is highest, next liquid, and then the last one will be gases, which have minimum force of attraction. Now, in order to understand much more deeper for this, we will do some experiment. Let's see experiment number 1. Here, okay, this is a conical flask, and here I have a dropper. I will drop this ink into this flask. Now, you can see that ink is getting mixed in the water evenly without me stirring it. So from this experiment we can see that they are continuously moving and they have spaces between them. Okay, they are continuously moving. Even if I'm not stirring it, it got mixed thoroughly. Next experiment. Here in this beaker I've already filled water. Water has been filled at 60 ml. You can also try this at home and check if it is true or not, okay? And then 60 ml of water. Here I am putting a spoon of salt, and then I will mix it, stir it. So after the salt gets dissolved, even after this, okay, after the salt gets dissolved completely, you can see that the level of water, which is 60 ml, does not change, okay? Here it might not be clear, but at home you can try it, and then from this experiment it is clear that they have space between them. So why the level is not increasing even though I have put a spoon of salt here is because the salt is occupying the space which the water is having. Okay, so from this experiment it is clear that this matter is having space between them. Alright, and also they have attraction, they have force of attraction in them. Okay, next we'll go to the details of solid, liquid and gas. Now what solid, liquid and gas are? Let's see the differences. Number one, solids, they have definite shape. This board is having a shape. This chalk is having a shape. So they have definite shape. They are solid, they are having definite shape. But liquid here, this is a beaker and this is a conical flask. The shape has changed. The water which I have filled is taking the shape of this beaker, taking the shape of this conical flask. So we can say that they do not have a definite shape. And gases, same with liquid, they also do not have a definite shape. Going to boundary. Since this board is a solid and it is having a shape, it is also having a definite boundary, distinct boundary. But liquids, they do not have distinct boundary, nor gases have distinct boundary. Next, rigid. Solids are very rigid or sturdy. Okay, they do not have the ability to flow, but liquids, they have the ability to flow. It is called fluidity. Gas also have the ability to flow. And number 4 is incompressible. Solids are quite incompressible. You cannot compress this board nor this straw. It will take a lot of energy to do so. So they are incompressible. Liquids, they are compressible, but not like gases. Okay, they are somehow compressible, and gases, they are highly compressible. Next is definite volume. Solids have definite volume. Liquids also have definite volume, but gas do not have a definite volume. So here I'll show you an example. Here, if I take a half liter of cup, 1 liter of water. Here I am filling 1 liter of water. If I pour it into a half liter glass, it's going to overflow, right? This 1 liter will overflow if I put it in a half liter of glass. But here in gas, see, this is a small container filled with gas. Now if I pour it here, it is going to take the shape of this container and then it's going to be filled, okay? And even if I pour this into here, the smaller one, it is going to occupy this space, just as it occupied this bigger space. So from here we can see that it does not have a definite volume. Now going to change of states of matter. The states of matter, solid, liquid and gas, are they interchangeable or not? Yes, they are interchangeable, okay? Solids can turn to liquid, liquids can also change to gas. But how and why? So let's see. The change of states of matter takes place because of the presence of some kind of energy. Just as we need energy to do work, different kinds of work, even for the interchanging of matters, the states of matter, it also needs energy. And this energy here, it is provided in the form of temperature and pressure. Temperature, let's see what temperature is. Here, temperature means heat. When we provide heat to solid, liquid or gas, it will interchange their states. Let's see how. For example, if I take solid in the form of ice, it will turn to water if we increase the temperature. If we increase the heat and if we apply heat, ice will change into water. Similarly, if we apply heat in this water, then it will change to vapor. And again, if we decrease the temperature, gas will turn to liquid, and liquid can also turn to solid, ice. If we decrease the temperature here, what is happening is, when we give temperature, when we apply heat on the state of matter, what is happening is, the force of attraction between the matter is getting reduced. The force of attraction is getting reduced. So when the force of attraction gets reduced, it is able to interchange their states. Now, in this, how this solid or this ice is turning into water. How ice is changed into water when we apply heat is because a point has been reached. which is called the melting point. And at this point, what is happening is that the amount of heat required to change this solid into water, into liquid, is reached. And that point is called the latent heat of fusion. For this melting point, it is called latent heat of fusion. Latent heat of fusion means the amount of heat required to change 1 kg of solid to liquid. And also in liquid, water is changed to vapor because this boiling point has reached. And how do we know the boiling point is reached is when the required amount of heat is reached. That means the latent heat of vaporization. The latent heat of vaporization is reached, and the latent heat of vaporization for pure water is 100 degrees Celsius. So in 100 degrees Celsius, it will start boiling, and so that is called the latent heat of vaporization. And lastly, in temperature, sublimation. So what is sublimation? Sublimation is the change of solid particle into gaseous particle without changing into liquid. So when a solid directly changes into gas without changing into liquid is called sublimation. Next we will go to pressure. Now, pressure is nothing but a kind of external force, usually a compression, okay? And here, when we compress something, things tend to come closer. So similarly, when we apply pressure to any matter, the space between them will decrease. The space between the matter, the particles of matter will decrease. And when that space decreases, the force of attraction becomes much greater, okay? The force of attraction increases. So, in pressure, when we apply pressure to gas will change to liquid. When we increase pressure, this gas will change to liquid. And when we again keep on increasing the pressure, liquid will change to solid. And it is also reversible. That is, solid can change to liquid when pressure is decreased. And even liquid can change to gas when the pressure is decreased. Here, an important point of this pressure is in storing gases. Okay, storing gases. For example, we cannot see gas. Gas is available everywhere, but we cannot see it. So when we cannot see, we also find it hard to store it. So when we apply pressure for storing of oxygen, LPG and CNG. Here, oxygen is stored in the form of liquid, which oxygen gas which we use in hospitals, it is stored in the form of liquid. So pressure makes easier for storing of gases. And similarly, liquefied petroleum gas, which we use in the kitchen, and then CNG, compressed natural gas, which we use in vehicles. So that is the importance of pressure. And one more effect of pressure is sublimation. Here, take an example of carbon dioxide in the form of solid carbon dioxide. It is also called dry ice. Okay, this dry ice, dry ice in the form of solid, it changes directly to gas without changing into liquid, and that process or that phenomenon is called sublimation. Okay, carbon dioxide, also called, when in the form of solid, it is also called dry ice, which changes into gas. Another example of sublimation is of naphthalene ball, a white color ball, which we use in our closets. We keep it between our clothes, and then after some time, when we go and check, we can see that it has been reduced. The size has been reduced, or it vanishes. Okay, and it does not leave any trail. That means it is in the form of solid, and it straight away changed to gas without changing into liquid. Usually, the matter changes into from solid to liquid and then liquid to gas. That is the actual process. But here in sublimation, solid will directly change to gas without changing into liquid. So that is all from this change of matter. Now lastly we will go to a very important topic, that is evaporation. Here, what is evaporation? Evaporation is the change of, it is a phenomenon of change of liquid to its vapor state at a temperature which is lower than its boiling point. It is a phenomenon of change of liquid to its vapor state at a temperature much lower than its boiling point. Here, why it is important is because here the energy usage is reduced. Okay, if, for example, if we have to keep on waiting for boiling point or melting point, we will be using too much of energy. So in order to reduce that, or in order to avoid the use of too much energy, here evaporation is an important phenomenon where there will be change from the liquid to its vapor state, but at a point or at a temperature much lower than its boiling point. But this evaporation is also affected by 4 factors. Okay, and those factors are: number 1, surface area; number 2, wind velocity; number 3, temperature; and number 4, humidity. Here, how surface area is affecting evaporation, let's see. So evaporation, we can take an example of drying our clothes. So when we dry our clothes, we try to expose as much surface as we can in order to let the cloth dry faster. So here evaporation is an important factor. Now, why we expose the surface and why we don't fold it? Because when we fold it, it will take much longer to dry for the cloth than when we expose the surface area. So here, when we increase the surface area, then evaporation will increase. When we increase surface area, the rate of evaporation increases. Next, wind velocity. On a windy day, usually the clothes get dry faster than on a non-windy day. Why? Because wind is helping the molecules, the tiny particles of water present in the atmosphere to go away from each other, and hence making space for more particles of water to stay there. So in evaporation, we know that it is change of liquid to vapor state. So water vapor present in the atmosphere is reduced. Okay, is reduced around the surface of the cloth when wind velocity is high. So accordingly, when wind velocity increases, evaporation also increases. Next, temperature. When temperature is increased, that is when heat is increased, then evaporation also increases. Why? Because temperature or heat is giving energy for the particles present in the atmosphere, the liquid particles present in the atmosphere, to move faster. Okay, that means it is providing some kinetic energy. So that's why when temperature increases, even evaporation increases. Lastly, humidity. What is humidity? Humidity means the presence of water particles, water vapor in the atmosphere. So when already water vapor is present in the atmosphere, then evaporation will decrease. Okay? With the increase of humidity, evaporation will decrease. Why? Because there is no more space for liquid to change into its vapor state. So that's why when humidity decreases, then only evaporation will increase. So that is all from this chapter. I hope you understood. Thank you for watching.